Hey everybody, it's Mrs. C, and I am coming to you today with a video that I feel my collection of videos is lacking. So as you see the screen, you probably get a feeling this has to do with linear equations, and you're right. Here's the directions, because when I took this picture off the internet, I kind of cut out, sorry, the most important part, which is the directions. So the directions are to write an equation in slope-intercept form of the line that passes through the given points. And that's it. They give you 2 points. Here we see right here. There's your 2 points. And they want you to write the equation of the line that passes through them. Pretty much that's it. And the form that they want you to use is slope-intercept. Now, I am going to do slope-intercept, and then I'm going to do standard, because a lot of you are struggling with standard form. I totally get it. I want to have a separate video just on standard for you. But I find that this is the one that probably creates the most trouble because it's the most involved. So, of course, that would be the one that's the most problematic. So I'm going to start with, not this one, because I want to start with one that doesn't have zeros in it. Just because the zeros have a tendency to throw you off for some reason, I understand. So let me go to maybe number 4. So let's take a look at number 4. I'm going to see if I can move number 4 around a little bit. I don't want to make it too blurry, because I know when I do that it makes it a little bit blurry, so apologies. Let me get rid of all this extra stuff. Okay, so if the directions are to write the equation in slope-intercept form of the line that passes through these points, let's just one more time get a little bit of intuition. There's the graph, right? Where would negative 4, 2 be? Well, negative 4, 2 would be 1, 2, 3, 4. There's negative 4, and then negative 2, 1, 2. So there's that point, right? Call that point A. In negative 4, 2. And then where would negative 3, 5 be? Well, negative 3, 1, 2, 3, 4, 5 would be up in that area, right? And let me just put that as a B. Wow, they almost look like they're right on top of each other, but they're not. They are sloping. They're sloping a little bit. Now, ask yourself, that line, is it a positive or negative slope? It's a positive slope. It's going up from left to right. And I think you guys are getting the hang of that. Looks like I'm passing or going to hit the y-intercept, which is my B, pretty far up there. So I'm anticipating a pretty big number for my B. So that's pretty much what I'm looking for. A little bit of intuition as to what we're doing. We're trying to write the equation of the line that's going to pass through those 2 points. So let's just do the math and find out what we get. Well, I have 2 forms, right? I have y equals mx plus b. That's called slope-intercept form. And I have, what's the other one called? What is it? Good. Thank you. Point-slope form. And that's this one, y minus y1 equals m times x. Forgot what I was writing. Minus x1. All right, now, those are my 2 forms. And you're saying, but what about standard form? Standard form, ax plus by equals c. Standard form is a form that you will put either of these 2 into. So, for example, you might have an equation in slope-intercept form and put it into standard, like so. Or you might have something that's in point-slope form and you'd put it into standard. It's like look, it's like a smiley face. It's the pretty form. And so you never take information, and I think this is a really good rule to live by. You never take information like what you're given up here. Let me just show you this. Never take that and try to go directly into standard. Standard, if you spell it right, I'm up at the top of my screen, sorry. Bad things happen when I get too far up. Standard form is a form that you use. It's like a presentation form. It's not one you go directly from the data right into. So you have to have a second step, and it's one of these guys. So you tell me, which is it, slope-intercept or is it point-slope? which of those two forms do I have information that I could plug into? Well, we don't have the slope for anything, do we? Here's the m right here, and the slope is required for both of them. And the problem is, I don't have the slope for either of them. I'm going to have to figure out the slope using the slope formula, which you guys are really good at. You've already done very well if you've made it this far to finding the slope given 2 points. I have every confidence, delta y over delta x, you'll be able to tell me the change in y over the change in x. It's the other question. You've got this b that you would have to plug into, or you have these x1, y1s that you'd have to plug into. So did anybody tell us the y-intercept? No, there's no y-intercept. There's 2 points. Oh, did you say points, Mrs. C? Yes, I said points. Thank you. Well, that's what those are. X1, Y1 represent any given point on the line. Oh my gosh, that's the form I should be using. I'm so going to do that. All right, now, we're going to use point slope form, and I know, I'm doing a peekaboo back, but that's just, I got to clear that whole screen. All right, we're going to use point slope form because it makes the most sense with the information that we've been given. So we're going to write it again. We have y minus y1 equals m times the quantity of x minus x1. And you might just go and plug your points in right now. That's fine. Let me do a change of color. Do a little bit of a nice black. Which point do you want? You can pick either one. I'm gonna pick that one because there's one less negative. I don't know. It's just the way I roll. So my x term is a negative 3. Excuse me. I'm gonna plug that right there. And my y term is a 5. And I write them right on top so that there's no confusion. Negative, negative, positive, and then I can rewrite y minus 5 equals m times the quantity of x plus 3. Awesomeness. Now, the x and the y always stay. They're always in our linear equations. The m, however, is a different story. Searching for the m, looking for it. I can't find it. Oh my goodness, where am I going to get it? Change in y over change in x. You have to come over to the side and actually calculate what your slope is. And so I didn't leave myself a whole lot of room to do that. So let me really quickly rewrite this. Now, while I'm rewriting it, I want you to go and start setting up your change in y over your change in x. Now, some of you do slope one way, some of you do slope another way. I'm going to do it the traditional way for this video, and that's to follow the formula y, oh gosh, what is it? I have to think. y2 minus y1 over x2 minus x1. You get as old as me, and you just do the slope. You don't even think about the formula. So we go ahead and we plug in our y2 minus y1, and if you're here watching this video, you should have already learned how to do slope. If you don't know how to do slope, please go back and watch a prior video on finding slope given 2 points. So we do the y2 minus the y1, which will be the plus 2, and we do the x1, which is the over x1, over, x1, which is negative 3, and it's going to wind up being a plus 4, because we have minus and negative. All right, I'm doing a quick little double check, and then luckily I have an answer key, so I don't have to worry too much if I screw this up. I've got a 7 over 1. Oh, that's nice. My slope is 7, which makes sense to me because on the picture that I drew, it was a very steep slope, and 7 is a definite steep slope, so I'm feeling good about that calculation. And now I have the number to put in for my m. It's 7. At least I think it is. Now, I just have to just do a little quick distribute here. So I have y minus 5 equals 7x plus 21. Another number that makes sense to me because remember I said it's going to be up pretty high up on the y. And this number by itself, when I combine it with that other number, is going to be my b. So I'm going to add my 5, and this whole thing makes complete sense to me. 7x plus 26. So there is my slope-intercept, and that is what they asked for in the directions. So I'm going to take you a little shot over at the answer key. I'm moving over to the answer key, shrinking it down so we can see it, and there it is, y equals 7x plus 26. You also see the answer key now, so if you do any of these that I don't do for practice, you know where you can go. Just rewind, and you can take a look at the answers. This is a CUDA created worksheet, but it did not come off of the CUDA site. It came off of some other page on the internet. Somebody like me made an answer key and shared it with everybody. Okay, so we've got y equals 7x plus 26, and I am in proper slope-intercept form. But what if the directions had read right in standard form? Well, you have a little bit more work to do, don't you? So if the directions had said right in standard form, that's ax plus by equals c, you're going to have to put the x and the y together. And so maybe you would minus the 7x from both sides. You can do that. Negative 7x plus y equals 26. And some of you are going, oh my gosh, Mrs. C, no. You can't have a negative x. You're right. I can't have a negative x. I'm supposed to change those signs. I'll make you positive, I'll make you negative, and I'll make you negative. And then that will be my proper standard form. It'll be a 7x minus y equals a negative 26. And that would be proper standard form. Dun, da, da, da. That would be both forms that you could use. And where's point slope? Point slope was way up here. So if the directions ever read right in point slope form, that would be point slope form. It would actually look like that. It always looks like it's not done, because point slope form is just a form you use to get to another form, pretty much. At least in my book, that's what we use point slope form for. It's not really a presentation form. I don't know why. It's such a pretty form, actually. Very useful. Okay. Here is, see the directions, right? The slope-intercept form of the equation. So I didn't actually cut it off. Good teacher. Good teacher. All right, which one do you want to do? Are you looking at them? I'm looking at them. What about, trying to say, there's a lot, they all look alike to me. Let's do number 5. Let's do number 5. I like number 5. All right, I have a change of color that I didn't mean to have. I like to use the bold colors. And let's just erase all this other stuff. And this is what I want you to do. I want you to pause me in a second, because I want you to do this problem by yourself. I'm going to write the points up here a little bit bigger. We've got a 5, 4, and we've got a negative 4, 3. Remember what you're going to do. You are going to try to write the equation of the line in slope-intercept form that passes through, sorry, I'm moving around a little bit, my apologies, that passes through these 2 points. I want you to write it in slope-intercept, and I want you to write it in standard form, and then I'm going to shoot the answers up, and then we're going to take a look at it and see. And I tell you, ask me some questions, but you really can't, can you? So think about your questions, and then when you come back to class, you can ask those questions. But before you do, what's your intuition? What is your thought process on what this is going to look like? What would the equation of the line that passes through these 2 points look like? So that when you're doing the math, like I did on the last problem, you can say to yourself, oh, that makes sense. It was a steep slope. It should be a whole number greater than 1, or wait a minute, I thought it was a negative and it should have been a positive slope. Have intuition about what you're doing so that when you're getting the answers, you don't need an answer key. You've got your mind. So let's plot. Where is 5, 4? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5, 4 would be somewhere around here. You would agree with me? Of course you would. Then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then negative 4, 3 would be somewhere around there. Now the line that would connect them, let's use an actual line. A line that would connect them would look ish. You can see I'm not hitting those points, but it is just a sketch, my children. Just a sketch. And so when we look at this, we can see what do we have? We're going to have a positive slope, and it's going to be hitting the y, like somewhere low. Now this is a sketch. I don't want to say it's going to be hitting at 0. I don't want to say it's going to be hitting at a half or anything silly like that. But I got to say, based on my sketch, it looks like it's hitting close to 0. And, so I want to keep an eye out for a very small number on my B. All right, good enough intuition. What are you supposed to be doing now? You're going to pause. You're going to do this on your own. Y equals mx plus b form, and also standard. And then when you're ready, come on back. If you get stuck, then just come back early. Okay, so hopefully you did what I was saying and you actually did the problem on your own. I'm gonna be quick about this, and I'm gonna actually calculate the slope first because I know I'm gonna need it. And guys, I'm gonna use what's called the arrow method. For those of you that use the arrow method, here it is. For those of you who've never seen it, well, hang on for the ride. We bring one point under the other, we change the signs of the point that we moved, and then we combine vertically. 5 and 4 is 9, 4 and negative 3 is 1, bring the one under the other, 1/9. I don't know if I'm going to buy into that. I'm going to look at the math one more time. It didn't look like it was that gradual to me, but I'm going to double check. And that is what I'm getting. Okay, so I have a slope that's 1/9. It's a positive, and that's the arrow method, guys. So for those of you that have never used the arrow method, and there it is. Now, it's bothering me so much that I do not have my formula written, so I'm going to go ahead and write my formula. Okay, I wrote it for you so you didn't have to sit there and watch me writing it, and I'm going to go ahead and I'm going to put in my M in a color. Let's do 1/9 right there. And let's pick a point. I'm going with 5, 4. And the reason I'm going to go with 5, 4 is just basically because I like to pick numbers that don't have negatives on them. So I'm going to pick the X as my 5 and the Y as my 4. Sometimes I look at it a little bit more, check out the numbers, the slope that's there, or see if there's a number that works nicely with it. But for this video, I don't really need to do that. So there's everything plugged in. And now there's my point slope form. And all I need to do is put it in y equals mx plus b form and standard form. Now, everybody out there seems to have an issue with fractions. And when you do these problems, you get fractions a lot because slope is often expressed as a fraction, as a rise over a run. So you're going to have to deal with fractions at some point in time. Now, ordinarily, I tell my students, I want you to do the distributive step first before you try to eliminate the fraction. And there's 2 reasons. One reason is because I find you make mistakes when you actually try to eliminate the fraction now. And the other reason is I really think you need practice multiplying fractions. It's not that challenging, and it's a skill you're going to need to use in the future. So I say, suck it up and let's do it. I'm going to actually show my process up high so I can erase this step when I'm done. So I'm going to say y minus 4. This feels so weird, doesn't it? 1/9 times x is 1/9 x. 1/9 times a negative 5 is a negative 5/9. As simple as that. That's how you multiply fractions, numerator to numerator, denominator to denominator. Now, if I kept the fraction, I would have to add and sometimes divide with them. So at this point, I would just recommend just get rid of the fraction if you're not a big fraction doer. If you're good at if you're good at working with fractions, then work with the fraction. Times both sides by 9. Now that's really 9 over 1. I don't have to show it if I don't have a denominator like on the left. I have no reason to write it as 9 over 1. That's 9y minus 36. But over here, it helps, I think, for you to see it as a fraction. Every 9 you see, here and here will cancel out. And then when you come over, here and here will cancel out. So that's why I'm multiplying by a 9, so that will happen. So 1/9 times 9 is actually just 1. x. And 5/9 times 9 over 1 is actually a negative 5 because the 9's cancel out. And there you go. The fractions are gone for now. I can just go ahead and work without them and not have to worry about anything. I've got a 9y equal to an x. What is that, plus 31? Yes, I believe it is. I'm just doing my double check. You have to minus. Yes, yes. I'm going to divide everybody by 9. Okay, so we have y equals 1/9 x. I'm trying to find a nice place that I can write this. Let me move everybody up just a scotch. Okay, y equals, we have 1/9 x plus 31 over 9. And we're going to leave it like that. Going to take a real quick peek to make sure we did that right. Peeking, we're peeking. Yes, there it is. 31 over 9. And I'm questioning it a little bit. I wonder if anybody knows why I'm questioning it. My b was supposed to be really low based on my sketch. And I don't know that, 31/9. Some of you might be thinking, I don't even know what the heck 31/9 is. Like, where is that on the b? Well, think about it. 9 goes into 31 how many times? 9 goes into 3. 9 goes into 3. 9 times 3 is 27. 9 times 4 is 36. So it goes about 3 whole times, which we never write as a mixed number, but it does help when you're graphing. So 9 goes into that 27, and then that would be how many left over? Good, 4/9. So about halfway, so about 3.5-ish. And that is contrary to the graph. So this is what I want to do. I want to graph 1/9 x plus, I want to graph this whole thing, actually. This is what I want to do. I'm trying to think of how to do this. I know my work is right. So this is what we're going to do. You're going to be patient. In fact, you're going to hold on, and I'm going to set the stage. So you hold. It'll almost be like I never went away. Okay, I am back, and it is all figured out. So for those of you that were out there going, what the heck are you doing? I figured it out. Okay, here is the graph of -4, 3. You see I put the point right there. Let me get my pen back. All right, here is my pen. Okay, there's -4, 3. We could call it point A. And over here is 5, 4. We can call this point B. And now look at the line. So if we go back, oh gosh, did I erase my intuition or is it still there? I erased it. When I graphed it, you're going to remember, because when I did it again, I did it the exact same thing. I graphed -4, -3. I graphed it down here. And the line continued to go as I graphed it right there. So that's why you've got to, when you're doing your little intuition, it's awesome because it'll make you think, but it'll also make you think you're wrong if you didn't graph it right and I wasn't paying attention and I plotted that as a negative, and it's not a negative. And you were probably wondering and probably yelling at me, but I couldn't hear you saying, don't go, no, you're not in quadrant 3. You should be in quadrant 2. It's a negative positive, but I didn't catch it, wasn't focusing on it. Here's what I should have done. I should have graphed it like this. And if you recall, when I was doing this, where's that process? And I got this 1/9. Do you remember me thinking, that didn't look like a 1/9 slope. It wasn't gradual enough. Look at how gradual a 1/9 is. So it goes up 1 and it goes over 9. And there's my slope of a 1/9. And then, of course, you remember what we said? It was about 3-ish. Look at this. 1, 2, 3, 4. We said about 3.5-ish when we got the math, when we got the answer right over here. We said 3 4/9. 3 4/9 was 31/9, and that's exactly where the graph is showing that it should be. So what happens is the algebra, the math that we used, took us to the right answer. My sketching of the graph, you saw it right there, right in front of you in real time, and I am not going to edit, except probably to put a little annotated note, so by the time you see this video, there'll be a little note letting you know that I'm making a goof, and hang on and watch to see me catch it. But I think the goofs are the most beneficial learning experiences, as long as, you know, those of us who do the videos catch them in time to not confuse you. So there is the graph. That is what it had to look like. Never planned on doing that. If you recall, I wanted to write it in standard form, but because of time constraints, I'm not going to do the standard form. I'm just going to show you the standard form. I'm not going to do it out in front of you because that would take too long of a video. So hold real quick and I will go ahead and show you the standard form as soon as I get it for you. Hold please. Okay guys, and there is the standard form of the equation. Y equals 1/9 x plus 31/9. So you see, really easy. Just multiply both sides by 9. These 9's, when it distributes, cancel out. That 9 times the y is 9y. And then all you have to do is move your x over, change everybody's sign so that x is positive. Everyone else is allowed to be negative, but x has to be positive. So it's okay for everybody else to be negative, but x has to be positive. Hey, those are the rules. Don't shoot the messenger. I'm not the one that came up with standard form. So, guys, you got lots of practice still to do. I apologize for the goof, but in the end, I think it's a great thing for you to see, and I hope you caught me. I hope you thought to yourself, wait a minute, I don't understand why you're graphing in that quadrant. Now, here's the practice, and here are the answers. Might as well do the practice with the answers right in front of you. You go ahead and practice writing them in slope-intercept. Be careful practicing standard form if you don't have a answer key to check, but this would be some great practice. There's lots of problems we still didn't do, and so you can go ahead and sink your teeth into those. And as always, I will see you guys on the flip side.